So what I want to do now is take a look at some programs that we've already written and just see how well they would satisfy the submission requirements if we were like hypothetically going to use one of these programs. Now, obviously you can't, you have to write your own program, but let's look at some things we've already written along with the requirements. So the first thing I have open is my message finder program that we used for the Snell project. And so let's go through here quick. Does it have instructions for input? It sure does. Here's some code that reads input from a file. So I've got that. It's got a list. It's got a procedure that has a name and takes parameters, contributes to the purpose of the program. Sure. It says an algorithm that includes sequencing, selection, and iteration that's in the body of the selected procedure. So, like here's a procedure I could talk about. It's got sequencing because steps are in order. This is my loop. It's got selection. It's in a procedure, which is a function. I do have a problem. There's no if else anything going on in here, so I wouldn't get the selection points. I've got calls to my procedures. They're all down here, and instructions for output. So those would be my print statements. These are the instructions to print on the screen. All right. So it's close, but let's wait till we get into the written response to see why we would lose that point for the selection. When we turn in our program, understand that we are not turning in actual code for anybody to run. They're going to get a PDF of the code and just look at it. And we're going to turn in a video of it running, and that's going to be the proof that it actually works. So if I were making a video of this program running, what I would probably do is go into the text files folder, open up a file or two at the beginning of my video, scroll through so they could see, what we're dealing with. And then I would run my program and watch all the print statements, start to happen. Now, I would let this run to the end if I were turning it into the College Board, but there's a 1 minute limit on the videos, so I'd probably let it run to the end, but I would crop out a bunch of the middle. So I just, I don't want to show 5 minutes of this. All right, so I'm going to close this out now, and we'll go back to the rubric. Okay, so that's our video. Now, the place where you're going to get your points is the written response. Turning in code by itself doesn't get you anything. The written response is where you prove that you understand how what you wrote works, and also you justify some of the design decisions you make. So some of it's going to be real easy. I would say the main thing is just make sure you answer each prompt thoroughly and completely, because there's no partial credit on any of this and any aspects of this rubric. And sometimes, 2 or 3 fields must be filled in correctly, and they're read together to get you a single point. Right. So there might not be any partial credit for, if you mess up any one of these 3 boxes. So keep that in mind. All right. So describe the overall purpose of the program. Well, I would say plain English here. The overall purpose of my program is to find small hidden messages embedded amongst hundreds of millions of randomly generated characters. That's the purpose. Describe the functionality demonstrated in the video. This would be a great place to say, well, in the video, there are 18,000 files, and they mostly with random text, and they are getting opened up one at a time sequentially. For each file, the characters are counted, and the chi-square statistic is counted for the character distribution, and those files that have distributions with unusually high chi-squares possibly have embedded messages, so those file names are printed. That's what I would tell them is in the video. Describe the input and output of the program described in the video. These questions, I think they may overlap a little bit in a lot of cases. So the input, there are 18,000 files, 10 that have messages in them, and you're trying to find them. And then the output is the names of files with unusual character distributions. So this is complete sentences, all but plain English. All right, so that's the first part. The first part, you're basically just setting them up to actually dig deeper into your code because now they know what they're seeing, what they're looking for. So the first part says capture and paste 2 program code segments that you developed during the administration of this task that contain a list being used to manage complexity in your program. So let's see. I have a list of character counts. So I would probably take this function, copy it over here. And says the second segment should show the data in the list being used. And that is happening in my chi-square function. So I would copy that over here. And now we have written response, which means plain English again. It says identify the name of the list being used. So, we got lots of variable names here. So you should tell them, the list is called counts. And in this particular case, it's being used in a different function. And so I would probably mention that, the list is called counts, but it's called nums when it's being used in the chi-square function. Okay, when it's passed into the chi-square function, nums is actually the same data. Describe what the data in the list represent. So here, it's, what is counts? Plain English. And I would say counts is a 95 element list where each number in the list represents the number of times a certain character appeared in a string of text. And I would even explain, so perhaps I would go a little further and say, for example, character 0 represents the number of times ASCII 32 occurred, which is the space. Counts element 1, counts 1 represents the number of times ASCII 33 occurred, which is the exclamation point, and so on. So give them a little context with it instead of just saying it's a list of numbers. Now, explain how the selected list manages the complexity of your program code. And here, I hope it's pretty obvious. All right, I'm trying to count the occurrences of 95 different characters, and I definitely do. So I would be explaining how without a list, I would have to have 95 different variables to keep track of the number of times each character occurred. So I would have to have a variable called num A's, num B's, num C's. And then when I'm doing my counts, I would have to say if the character's an A, then num A's plus equals 1. If it's a B, then num B's plus equals 1, and so on. So I would have 95 different variables plus a lot of if, else, elif, 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 else to deal with all of that. Never mind. The other place that would be really difficult is if I had 95 different variables to deal with, I couldn't use a loop to iterate through them to compute the chi-square statistic. So, and generally, like with this part, what you're going to see is the list saves you from having lots and lots of different variables, and it also allows you to use a loop to iterate through it. Those are the things you mostly see there. All right, so that's our list. Capture and paste 2 program segments you developed that contain a procedure that implements an algorithm used in your program and a call to that procedure. So the first program code segment must be a procedure that defines the procedure's name and return type if necessary. So I'm going to pick my chi-square function. So here's a procedure that defines this is the procedure's name. Don't worry about the return type, right? We return a value down here. What they're saying is there are some programming languages like Java, for example, and C that in the first line in the function, the line that defines the function, that there might be some other code in here that says, hey, a floating point number is going to be returned at the end of all this, but Python doesn't have that, so we don't need to worry about the return type. Contains and uses 1 or more parameters. Got that. There's my list that goes in, and it has an effect on the functionality because we get different output for every list. And then implements an algorithm that uses sequencing, selection, and iteration. Right. So this is the first place I want to see their code. I think our code is good here, but it actually doesn't quite meet everything they want in the rubric. Right? We have sequencing because you've got steps that get executed in order. We've got iteration because we have a for loop. We don't have selection because I don't have any if, else, or if, elif, else in here. So when we have to start talking about the selection in here, there's going to be a point or two that we don't get. And I'll show you a way we could maybe fix this code. All right, so So the code segment, let's just suppose, I'm going to use it even though it's not good right now, but I would take this and I would copy it in here. And the second segment shows where your procedure is being called. So chi-square is my procedure. So I would say it's being called down here, and I would copy and paste this chunk of code, right? And I'm getting the lines around it for context. And when we actually submit college code to the College Board, we're going to be doing screenshots, not like copy pasting. So I might give them a screenshot of this, and before I turn in the screenshot, I might highlight or circle this line right here that shows the chi-square. Well, there's the call function that shows the chi-square function getting called, right? So that's what I paste here. Now we have to talk about what it does. This is where it gets real tricky, and you want to make sure you get full credit. Remember, no partial credit. So when you start seeing the word "and," you better do both parts. Okay, it's not hard. Just read closely. So it's describe in general what the identified procedure does. So I would say it says in general. So I would say the chi-square function takes a list of integer values and returns the chi-square statistic for that list. Now, how it contributes to the overall functionality of the program, this is where you need to say, later the chi-square value is checked, and if the chi-square value is above some threshold, then the character distribution might be unusual, and that's an indication that there could be some non-random, perhaps secret message embedded in that text, right? So I would explain, yes, it calculates the chi-square, but I would also explain why we care about getting that chi-square value in that. That's an indicator, we might have found a message. Explain in detail the steps. So here's my algorithm, and you aren't going to need to go, they don't expect you necessarily to go line by line and explain what everything does, but you're going to have kind of blocks of code, and you should explain what each one does. And so, and use good order words in here. So I would say well, first we calculated the expected value, which is just the average of all numbers in the list. Then we made a variable and initialized it to 0. Then we looped through each value in the list, and we computed the chi-square, each chi-square term, and added it to the chi-square sum, and then we return the chi-square sum value at the end. So that's what I was explaining to them here. I'm taking them through this, if not line by line, at least block by block, and explaining what happens. Remember that the person reading your program, they might not, they definitely know code. They may or may not know the language you're writing in. So, but even if somebody didn't know Python, they would be proficient enough to understand what's going on here, so long as there's a good explanation. All right, so that's easy. Now we're going to look where we get in trouble with the selection. So it says describe 2 calls to the procedure. Each call must pass a different argument that causes a different segment in the code to execute. And so these can be hypothetical. And, so if I had a call that was chi-square 1, 4, 3, 2, 6, and another chi-square that was 0, 0, 0, 12, 8 or something like that, obviously I would get different results from each of these values, but they don't cause a different segment of code in the algorithm to execute. So what they are looking for, and that's because we don't have selection in here. So what they're, if I wanted to modify this code, perhaps I could do something like this. I could say if the chi-square is greater than threshold square, and we could pass in maybe the file name too. Kind of a weird order. let's say our chi-square took in the file name, the threshold, and the nums. Well, then we could say, we could print we could say if the chi-square is above some threshold, we could print the file as unusual, and then we could say else print, and we'll just say nothing to see here. Okay, so now we have selection, and what I could do is an example call of a file that had a relatively even distribution. So I could pass in a relatively even distribution of numbers and say if this happened, it would, and then do it, something that would make this branch of the if else statement execute, and then a second call that might make this branch execute. So the conditions tested by the first call, what they would want, you would say, this is a relatively even distribution, so it should produce a low chi-square, and say that there's nothing to see here. And in the second function call, we sent in an uneven set of numbers, so the chi-square would be high, and it would print that file name is unusual out. And then the result of the first call and the result of the second call, it would be just the output from each of these print statements in this case. All right, so we wouldn't be able to get our code as until I added this part in here, we wouldn't be able to get credit for this section because we don't have something where they're looking for something where at least one of the arguments up here causes a different branch of some kind of conditional block to execute. All right, but the program is pretty close. Now, in our case, I don't think this is a good idea because we're going through 18,000 files, and I don't want to see nothing to see here printed out nearly 18,000 times. I structured it the way I did because we only needed to see the important files. The rest of it we don't care about. So I think this is better code, but I wanted to show you how it doesn't quite match their rubric. So keep that in mind. There could be a point where you have to just do a little bit of fiddling to get your code to satisfy everything in their rubric. All right. I'm going to look at one more program, and we'll look at that old rabbit attack. And sorry, this video is getting a little bit long here, but so this one's pretty good too. It almost does everything, right? We'll go back, and it's got user input because we're doing the use grenade right here. It's asked, we're getting the inputs in the yes no function. So it's got user input. It's got procedures that have names, and some of them return values, and some of them take arguments. So that's pretty good. It's got sequencing, selection, and iteration. Let's see. Obviously have sequencing. I've got multiple statements in order. I've got selection here. I've got selection here. I've got selection here. So there's lots of selection in functions. And then I've got iteration because so this time I'm not iterating through a list. I'm just iterating until some condition is met, but I've definitely got iteration here. So it looks pretty good. Calls to my procedures. Sure. There's my play function. And I've got output because there's my print statements. So, it looks good. But let's think of the problems we might have. So we got the purpose is to play a game where you're trying to kill a rabbit. Let's see. But data being stored in a list. All right. So I have a list here. However, I am going to argue that they won't give us credit for this because I don't think this really manages the complexity of the program. We certainly could have just said if answer equals yes or answer equals y, and it has the exact same effect. So really, the reason I use the list here is because it makes the code look a little bit nicer and easier to read. So I don't think this is one that manages complexity of the program. And even if I wanted to add, one or two extra acceptable responses, that really isn't that difficult to do with just or equals and ors. So I don't think we'd get the list I don't think we'd get full credit for the list section here. Let's see. A procedure that has a name or return type, uses parameters, implements an algorithm with 6 sequencing, selection, and iteration. Well, so we've got sequencing, we've got selection, I've definitely got iteration, but my problem is that this algorithm does not take any arguments, right? The play function doesn't take anything. And so we wouldn't quite be able to use this. Just so, and then the other one is, depending on the arguments passed into the function, we should get different selection should occur here. So, I might want to do something like input equals, or name equals input and we could do this, and we could say play name, and then we could pass name in, and then we could say sir and we could make this program refer to it by name as we run this program. But that doesn't really do it. It doesn't really satisfy the requirement either, because nothing about this argument that gets passed in has any impact on the sequencing here. So we have to, whatever function you choose to write about for this written response, right? It's kind of tricky sometimes to make sure that all of this stuff here occurs in just one function. I think sometimes, I kind of disagree with this. I think in some cases, if all of this stuff is occurring in a function, then maybe it should be broken up into 2 functions. But I think they're at the College Board trying to make this reasonably easy to grade. So they're trying to, it's like, hey, these are some major concepts in computer programming. Let's make them write a program that has all of them basically in one place. That way we can look at it real quick and assign a grade. All right. So that's how the rubric works. Hopefully you can see you're not writing anything, super duper complicated. These programs I've shown you certainly are long enough. So you just have to come up with something similar, and you might have to do a little tweaking to design just in order to satisfy the rubric. All right. So that's all I've got for this video. And if you have any questions, let me know.